Hi friends, the subject of this lesson uniform circular motion. Uniform circular motion. Other lessons uh, lessons just looking on the line and in this lesson looking to the circular motion. For example, that's our circular pivot. For example, that's our circular pivot and the center of this circle, and that's our radius r. And there is an object, and this object moving on these circles the stable velocity, and this velocity is we know that the vectoral things, and this velocity's value is the stable, is y, and this velocity not changing time by time, and intensity is equal to y. For example, in here, stable velocity, and here stable velocity, and here stable velocity. Yes, not changing on these circles. But velocity is the vectoral things, and if a vector's changing a direction, this vector's changing. And now in this moving, our velocity is stable, intensity is stable, but direction is changing, so our velocity is changing day by day with the angular yes, with the angular with the amplitude changing our velocity direction, and also changing our velocity. And if the changing velocity there is a acceleration, but this acceleration direction is the center of this circle. Yes, that's our acceleration direction, and this acceleration name is centripetal acceleration, and centripetal acceleration showing to AR, and also vectoral things. And this acceleration, centripetal acceleration, this acceleration occur to changing velocity direction, and our velocity direction changing, this velocity is the changing, and if the velocity changing occur a acceleration, and this acceleration name is centripetal acceleration, and its direction is the center of this circles. And this acceleration's value is r v square divide radius, and that is the linear velocity. linear velocity. Linear velocity, and that's radius and also centripetal acceleration. And centripetal acceleration also the vectoral things. That's important. And the other way of occur to acceleration, changing the linear velocity intensity. Let's looking on the other figure. Yes, drawing to other figure, and also our center of the circuits, and that's also linear velocity, and that's also 1, and radius. And day by day this velocity, linear velocity, is changing now, not equal to the others. And let's looking here. Yes, and not equal to the others. If the linear velocity changing to be an acceleration now, but this acceleration direction to the linear velocity. Yes, and this acceleration is tangential velocity. Acceleration. Yes. And this acceleration occurred to changing velocity, linear velocities values, intensities. But the centripetal acceleration occurred to changing stable linear velocities direction changing, occurred to direction changing. And there is there are two acceleration types in here for circular direction. And tangential direction may be occurred, but the centripetal acceleration always occurred on the circular motion. And our total acceleration, sum of these two acceleration type. And let's looking to another figure. For example, our circular shape, and also our linear velocity is changing on the circular trajectories, and also changing to linear values occurred an acceleration, tangential acceleration, and that's also tangential acceleration. Direction also same direction to the linear velocity, and always occurred to occur to centripetal acceleration, or yes, always occur to centripetal acceleration, and our total acceleration is vectoral sum of these two acceleration, total acceleration, and in here total acceleration is this one, total acceleration, and that's total acceleration equal to sum of the centripetal acceleration and the tangential acceleration, and this sums is the vectoral sum. Yes. Vectoral sum. And since velocity is a vector, there are two ways acceleration can be generated, and the first one is the change in direction of velocity change in direction of velocity, and that is the this acceleration type name called is the centripetal acceleration, and the second way is occur to acceleration change in velocity, change in linear velocity. And this acceleration type called is the tangential acceleration. Tangential acceleration. When the object has a constant velocity, when the object has a constant velocity, the cause of the acceleration is the change in the direction of the velocity. The velocity vector is always tangent to the particles path and is perpendicular to in this motion. Yes. In this motion. Yes. And yes. And linear velocity changes continuously with angle change the direction of velocity creates acceleration. And this acceleration is called centripetal acceleration. Centripetal acceleration. And if we are looking to linear velocity equal to angular velocity multiplication to radius, and in here that is the radius and that is the angular velocity, and that is linear velocity. And angular velocity independent on the frequency multiplication to frequency, that's also frequency, and that's also the 360 degree, the type of the the type of the 360 degree is the type of the degree, and that's also the radiant type of the degree. Radiant. And that's also angular velocity. And our frequency depend on the period. Period unit is the second, and also frequency unit is the 10 to minus 1 second. Second to minus 1. Yes. Frequency unit is the second to minus 1. Yes. And if we are writing to the period kinds to the angular velocity, yes, that's also period, and these are angular velocity, and also this term equal to this one. Yes. And this movement same as the pendulum moving. That's also a pendulum. And these are equilibrium position. If it has a amplitude, for example, that's there is an angle and occur, and the amplitude of our mass make an circular trajectory moving. If we are drawing to this one, occurred this trajectory is an circular trajectory, and so there we have a centripetal acceleration showing the AR centripetal acceleration, and also changing to linear velocity on this trajectory, and occur a tangential acceleration on this trajectory. AT, yes, and also our total acceleration is sum of these two acceleration, and that's also total acceleration now. And the tangential acceleration occurred to an gravitational acceleration, and that's also gravitational acceleration, and for example, that's the angle is the theta, and the gravitational acceleration occurred to tangential acceleration, And so the gravitational acceleration occur and the gravitational force, and this force moving on the this object on the circular trajectory and changing day by day, daytime day to on the trajectories, and if has a forces on the direction of the linear velocity occurred, and the tangential acceleration now, and also the also occurred to the centripetal acceleration to direction to center of the this circles, and total acceleration occurred to vectoral sum of this tangential and the centripetal acceleration. And if we are looking here, if has a acceleration, if has a acceleration in here to the centripetal acceleration must be to a force, and this force name is and this force name is the centripetal force. This force name is centripetal force, and the centripetal force direction is also to the center of the circus, and that's showing to F R, and this FR's meaning of the centripetal force. All of the force equal to m multiplication to acceleration, and centripetal force equal to m. M is our object mass, and multiplication to centripetal acceleration. And our centripetal acceleration value is linear velocity square divide to radius. Yes, that's also our centripetal forces. And if as a forces occurred a reaction force, so that is the that system is in the balance, and if the system balance, all of the forces occurred a reaction force, and this force name is centrifugal force. Centrifugal force, and this force equal to the intensity is centripetal force, centrifugal force, centrifugal force, and this force equal to centripetal force to intensity is the equal to the centripetal force, but the opposite direction of the centripetal force. But in the some exercise using the centrifugal force, so that's also equal to intensity, and this is sometimes using to this centrifugal forces, and not using to centripetal force. Let's look into this exercise. Yes. Yes. And the car whose speed increases by a value of 0.6 meter per second square moves along a circular road with a radius of 20 meter when the instantaneous speed of the car is 4 meter per second. Find the acceleration, tangent and acceleration and B centripetal acceleration and G total acceleration. Yes. And if we are drawing to our trajectory, some parts drawing here to our trajectory, and the radius of our circus is 20 meter, and our object in here, and our linear velocity is instantaneous speed, and in here to velocity is 4 meter per second, and there is a two acceleration on this movement, and the first acceleration is the direction of the center of the trajectories, and that's also centripetal acceleration and showing to AR. And the other acceleration is in the same direction of the linear velocity, and this acceleration name is the tangential acceleration and showing the AT. And AT, we can understand the AT values of this one. That's also our tangential acceleration value, and meter per second square is our tangential acceleration value. And if we are find to centripetal acceleration, we can using to equation where is this equation? Yes, that's also our centripetal acceleration value, and our centripetal acceleration depends on the linear velocities and the radius, and for square divide to 20 meter radius, and centripetal acceleration find in here to the 0.8 meter per second square. And if we are sum of these two acceleration, we can find the total acceleration, this B and G, and the total acceleration is to this way. So the acceleration is the vectoral things, and this sum is the vectoral occur to vectoral sum, and dot 6 square plus dot 8 square, and that's also the vectoral sum. And we are find to the total acceleration is 1 meter per second square.